Okay, another aviation video on the subject of aerodynamics. Okay, if an aircraft is in a steady climb above the horizontal, is there a way to calculate the ground speed and the rate of climb? Yes, there is a way to do so. The way to do it is to replace the aircraft vector, to replace it with two or more vectors. In this case, what we need, because we need the ground speed of the aircraft in steady flight, and we need to know the rate of climb. So needless to say that we need, if you're going to replace the aircraft vector with two other vectors, which if you add them, they will produce the initial aircraft vector. So needless to say, they have to be VH, which is parallel to the horizontal, and VV, which is a vertical component of the initial aircraft vector. So basically what we're doing, okay, we have the aircraft vector. Let's say the aircraft is climbing at a rate of 200 knots, at a speed of 200 knots, for example. And then the path makes a 30 degree angle with the horizontal. So now we need to find the ground speed and the rate of climb in this case. Okay, just like I just mentioned, to do so, you replace the aircraft vector with two vectors. It's going to be VH, that means horizontal vector, and VV, which means vertical vector. Okay, and those two vectors, those two replacement vectors, they are called component vectors, and they are, if you add them together, they will produce the initial aircraft vector. So what you do in this case, you have your horizontal, okay, and the aircraft is climbing, and you have the above the horizontal, and then the path of the aircraft make a 30-degree angle with the horizontal. So now what we need to do now is to draw a line, a vertical line from the horizontal, okay, to the aircraft vector, to the head of the aircraft vector. Okay, this is the aircraft climbing. This is the horizontal, and this is your angle, the 30-degree angle. Then now you draw a line from the horizontal to the head of the aircraft vector. And so when you do that, okay, when you do that now you have what you do now, you're going to, what you have now, you have the VH, which is the ground speed. Okay, VH. Okay, you remember you created two more vectors. The VH is parallel to the horizontal. That's the ground speed, and then the vertical vector you just created. That is the claim. That is the rate of climb. Okay, but how do you calculate this VH? Okay, the ground speed VH and the VV, the rate of climb. How do you calculate? How do you find those two? Okay, this is where trigonometry comes into play. Okay, in this case, remember now we're talking about finding the ground speed and the rate of climb. Okay, when an aircraft is in a steady climb. Okay, now the way that you find the ground speed in this case, which is VH is, okay, VH, which is horizontal, equal, okay, first of all, let's talk numbers as well. Let's talk numbers. The aircraft is climbing at a speed of 200 knots, and the flight path makes an angle, a 30-degree angle with the horizontal. We need those two numbers in order to calculate the ground speed and the climb and the rate of flight and the rate of climb. This is where, once again, trigonometry comes into play. First, the ground speed in this case, VH, that's a horizontal vector parallel to the horizontal. That's the ground speed. The way you find it is by this formula. VH equal VAC. VAC, that's the aircraft vector, time cos 30 degree. You remember that 30 degree angle? Okay, once again, VH, the ground speed equal VAC, that's the aircraft vector, 200 knots, okay, time cos 30 degree. And what you get is the result of this calculation is the ground speed of the aircraft in a steady climb. Now, the rate of climb, the formula for the rate of climb is kind of similar. Okay, VV, vertical vector, that's the rate of climb. The formula VV, vertical vector, equal, once again go back to the original vector, aircraft vector, which is 200, okay, VAC time sine 30 degree equal the result, that's the claim, that's not the claim, that's the rate of climb when an aircraft is in a steady climb. Okay, I hope I give you I know I gave you the right formula, but I hope I didn't make any mistake by doing so. Or I can let me give them to you again, just in case I made a mistake. V as in Victor, H, that means horizontal vector, horizontal vector parallel to the horizontal. That's your ground speed. The formula is VH equal aircraft vector VAC time cos 30 degree angle. You remember that 30 degree angle created by the aircraft path and the horizontal? Okay, the result of this calculation is the ground speed. Now let's go for the claim. Why am I saying claim? Now let's see the rate of climb. Okay, VV, that means vertical vector, that's the rate of climb. Now we go back to the original vector again, aircraft vector VAC. So VV equal aircraft vector VAC time sine 30 degree angle, and the result is the rate of climb, and you're going to get a number for that, a number, okay, for the ground speed. The result is going to be in knots, and then of course when it comes to the rate of climb, it's going to be in knots as well, but you're going to convert it into feet per minute, and that's it. Once again, this kind of calculation, when it comes to an aircraft in steady climb, this kind of calculation is called vector resolution.